All right, so I have some chloride salts here in the tray, and I have calcium chloride, lithium chloride, sodium chloride, strontium chloride, copper chloride. And what those are is salts that have been dissolved in water, and the thing that is different between them or among them is the metal that is with the chloride. So let's just take a look at sodium chloride. All right, we're going to put that in the flame and see that that has a really pretty sunshiny yellow color. Okay. Then calcium chloride has a similar color, maybe a little more orange. But let's contrast that with lithium chloride, which is crimson, and copper chloride, which is green. And one last red one, strontium chloride, which is in the kind of brick red. Don't want to burn down there, it's going to burn up here, kind of a brick red color. So we're going to turn that burner off and look really quickly without making you sick at an isotopic symbol for sodium. That's one of the ones that we saw that was sunshine yellow, and the isotopic symbol, if you recall, has the atomic number down here, the mass number up here, and then up here is charge, and let's make this charge 0 because we have a neutral atom. Okay, so let's look at that neutral atom. In the nucleus, I have 11 protons and 12 neutrons. And that's the nomenclature used sometimes when you don't want to draw 11 dots and 12 dots. So sometimes the nucleus looks like this. Okay. So when we were looking at the drawings that you did, we needed a little help sometimes on the order of fill for electrons. The maximum that can go in this smallest energy level is 2. So we're going to put 2 of them here, right? And then that's full. I can't put any more there. And because this is neutral, if I have 11 protons, I'm going to have 11 electrons. So I'm going to have to put 8 out here. My arm's not going to be long enough to video this and draw it, but we'll draw it. We'll put 8 dots. All right. So now we're up to 10, which means that that 11th electron, because 8 is all that the second level can hold. So now I have to move out to a third level and put 1. So now we have a new concept, and that is something called a valence electron, or valence electrons. And we're going to learn about those with our periodic table trends. And sodium only has 1. And so valence electrons are the number of electrons found in the outermost energy level. Well, now I've drawn a 4th dotted energy level because just a minute ago we excited sodium and some of its electrons were allowed to go to higher energy levels. So we're not really sure when we excite an atom where the electrons have gone to, but we know that they can move to an outer level, right? So let's say this electron, among others, moved out here to this location. It can't stay there forever. It's going to have to return back. And when it does, it's going to give us some light. That's where light comes from. So when it returns back to a lower level, it is going to give that energy back as a photon of light. And that photon of light could be red, it could be yellow, it could be orange, Roy G. Biv, and more.